Hi, in this lecture we will talk about traits in Rust. With traits you define the shared behavior across different data types. It's very similar as interfaces in other programming languages, but it also has some differences as it will be shown in this lecture. So here in this example we have two structures that represent the shapes. And we want to achieve something like this. So we have some function that can accept any shape, and it can call the method for calculating area on this shape. Okay, I will comment this function, so that we don't get bothers with errors. So the first thing that we need to do is to define a trait, and here is how you define it. So you have the trait keyword, then you have the name of your trait, it can be any name, and then inside you have the methods that your objects will be implemented. And here we have just a single method that our shapes will be implementing, so yeah, to calculate the area of the shape. Now that we have this area trait, we need to implement this trait for our structures. So first we will do for circle. So to do this you need this implementation block. So you have impl keyword, then you specify the name of your trait and for which structure you want to implement this trait, like this. And inside the curly braces you must implement all methods that you define in trait. So here we have this area method. It's so to calculate the area of the circle we use just simple formula, and this is it. Yeah, so we implement this area trait for our circle, and now we will use the same. Yeah, it's very similar to do this for rectangle. So yeah, I will just copy this. Yeah, it's same, just different formula. Now that we have these traits implemented for our structures, we can finish this function that we start at the beginning. Here, so I will uncomment this function, and now we will say here that we want to accept any shape that has the area trait implemented. So, and we do this like this. Yeah. So here, as I said, now we accept any shape, or more generically, any object that implements this trait. I will do this, just that you know that this area. And then here in the main, I instantiated these two objects, and I will uncomment this. So yeah, so you call this method with a different shape, as you see here. And I will run it just so that we can verify the results. And we see here below. So yeah, this is how you define the shared behavior in Rust. Here, inside our trait definition, you can have as many methods as you like, and you can also provide default implementation for methods. So here I add the volume method, and I also call the other methods from this trait. And yeah, and when you have like this, then objects doesn't need to implement this volume method, because we have implementation here, but they can override this if they like. Yeah. One thing that you cannot do is to add these data fields inside your trait. This is forbidden. As you know from previous lectures, you can call methods on primitive data types, and with traits we can extend this with new methods. So here I will just show you a small example. So we have here simple trait that will calculate the square of the number, and here is implementation for our floating point data type. And now we can call this in our code. I will show you this. So here we have this primitive data type, and we can call this square method that we define using trait. We can run, and we see that square is 9. In Rust standard library, there is a lot of traits that you can implement for your objects. I first thought that I will list them here, but there is literally hundreds of them, so I will not do that, but instead we will implement some of them in this lecture, and most of them will be implemented in future lectures. As you can see here, you can easily print the values from the primitive data types, but if you can try this for your custom data types, you will get an error. So we can try something like this. So here I just want to print our circle shape, and then Rust will complain. As you can see, we got the error. But also Rust compiler will not show only errors, but he also will show you hints what to do in this situation. So here is the hint that we need to follow, and that is to display that is to implement this display trait. And if we implement this, then you can use this syntax to display your custom shape. So now we will implement this display trait. First, we will import this format module. Okay, there will be another lecture about the modules, and now we will implement this display trait for a circle like this. Okay, and this trait requires us to implement this formatting method, and here we will construct a string. He also sent us this argument that you can use to construct the string, but there is also the simpler way how you can do this using the write macro. Yes. So this write macro is first argument. It accepts any object that has this write formatting method. So this, and then these other arguments are the same as for print macro. So here say that this is circle, and then radius of like this. Yeah, and that's all that we need to do. And now we can try to run a program again to see is it working. And yeah, you can see that this macro print is working as for primitive types. Another benefit that you get for implementing this display trait that now you can call toString method on your object that will return the string, and that is because there is another trait in string module that is called toString, and default implementation of this trait is to call this method that we just implemented. I can show you. So this is this string, this trait from standard library toString, and here is default implementation of this trait. And as you can see here, he just instantiated this string and this formatter and called this method that we just implemented. Yeah, so now you can call this method on your shapes like this. Yeah, and run the program. There is also many special traits in standard library. These traits are known to Rust compiler. So for example, using traits we can overload mathematical operators. So here we have simple structure that represents small vector, and now using traits we we will overload plus operator for this structure. First, we will import module where are these mathematical traits, and then we will implement this trait for our structure. You can see here there is a trait for every mathematical operation. We will implement this add for our structure. Okay, so all that we need is to implement this add method. Yeah, don't be afraid about this little bit maybe strange syntax. So we can go just to see how these traits look like. So basically he used these generics, and this will be explained in the next lectures. So yeah, I will not bother explaining all this now, but this trait also requires us to specify this output from this plus mathematical operation here, and this is the signature of this trait. But as I said, we don't need to bother with this special syntax here. So for the right hand side you can specify that it will be vector, and also for the return type also to be vector. But we must specify this as you see, this type output, and this will be of course also be vector. So yeah, and now we need to add implementation. Implementation is very simple. You just need to add components of the vector individually. So yeah, so here is simple implementation, nothing special here. So yeah, and now all that is left is to test is this working correctly. So here at the bottom I will add a small snippet of code. So here we'll instantiate two vectors, and we will add them together and print the result to see, to verify is it working correctly. And you see the output here. So yeah, so and that's it about traits in this lecture. See you in next lecture. Bye.